Okay, so here we have integral exponents. Wow, integrals, huh? So here we have five questions. So let's try 'em. So here the first question says that we have 2/3. What the heck is that? 2/3 to the power of -4. So whenever you have a negative, right? Whenever you have a negative exponent, all you can do, you can just take that and put it under a 1. So it'd be 2/3 to the fourth power, just like that. And then we see that we have a fraction here. We can just distribute the exponent like that. So just have 1 over. So 2 times 2 is 4. And then 4 times 4 is 16. So this will be 16 over 3 to the fourth power, which is, you know, not going to cheat or anything, using a calculator or anything. Um, so in my head, I said that was 81. And whenever you have a 1 over a fraction, all you have to do is just flip what's in the denominator. So you can just do 81 over 16. You can simplify it, but it's okay. I was going to still that as the answer for number 1. Alright, number 2 says that we have a big boy bracket of 1 minus 1.01 to the negative 20th power over 0.01. And whenever you have a decimal, it's always good to put it into a fraction whenever you're doing algebra. So let's try and do that. And also we have a common denominator of 0.01, so we're going to split the fraction on the top. So we're going to have 1 over 0.01, and 0.01 is just going to be equal to 1. It's going to be equal to 1 over 100. So we have that. So then we're going to minus a 1.01, and then to the negative 20th power over 1 over 100. So here we see that we have 1 over a 100 over 100, and this, we just flip this, so it'll just be 100. And then minus, we have a 1.01 to the negative 20th power. So what I'm going to do is I'm going to bring that down as 1 over 100, and then it will be times, I'm going to do that as a times symbol, of 1.01 to the negative 20th power, just like that. So now we see that we can just flip it. So here we can just flip this and flip that. So this will just be 100. And then we have this. Let's not flip it actually. Then I'm thinking about it. Also, this is not supposed to be a negative 20, it's supposed to be a 20. So we have a 20 like that. So we have a 1 over 100 times a 1. We can just bring that to the top, right? And then we have a new fraction. So we just flip it. So this will just be 100 over 1.01 to the 20th power. And then we see that we have 100 on both sides, so we can just factor that out. So we have a 1 minus, and then we have a 1 over 1.01 to the 20th power. We don't like having decimals as a denominator, but if you want, you can flip it a little bit. But I'm not going to do that because I'm a little lazy, and I don't want to do that, so here is the answer. But yeah, close enough, I guess. So here we see that we have a new one, which is going to be -1 cubed, and then -1 to the 7th, and then -1 to the 5th. So whenever you have -1 like this, and you have a power, it really does depend on the even, if it's the numbers even or odd. So it's very simple. Let's say if we have -1 to the even power, it can be any even number, it's just going to be equal to 1. If we have -1 and it has an odd power, it's just going to be -1. We see that all this is just going to be odd, which is all going to be -1. So it's kind of like saying we just have -1 times -1 times -1. We see that we have a -1 will just become a 1, and then times a -1 is just going to be a -1. So the answer to that is going to be -1. Yeah, pretty easy. Okay, so now we see that we have an x to the 4th times x to the 5th over x to the 7th. We can combine the top because they're multiplying. We can just add we can just add the exponents. So this would just be x to the 4 plus 9 over x to the 7th. I mean, not 4 plus 9, 4 plus 5, which is gonna be x to the 9th over x to the 7th. So we see that we have a 9 up here, a 7 up here, same base. So whenever we're dividing base with this, whenever we're dividing the same base with, whenever we're dividing the base with the same base with exponents, you're just going to subtract the exponents, so it'll just be x, and we take the top, so we do 9 minus 7, which is just going to be x to the 2nd. So that's the answer. Don't know why the hell I stuttered there. Lastly, we have a cubed b squared to the 4th over x. Oh, just kidding. The r to the 4th. Yeah. Okay, so whenever we have a 4 raised to a fraction, you can just distribute the power into the numerator and denominator. So, okay, so this would just be equal to a cubed, and then b squared, and then this would just be to the 4th power over x to the 4th. So the top is, the bottom is done, but we have the top. So whenever we have multiplication, again, just like the fractions, whenever it's multiplying two of like two functions, you can just distribute the 4 into each of the functions that's being multiplied by. So this would just be equal to a cubed, so this would be 4 cubed, so this would be 4 times 3. If you're doing a power to the power of a power, it's just going to be this times that, so this would just be a to the 12th power. This would just be b to the 8th power, and then this would just be over x to the 4th, and then this is the answer. So that's the first part. Okay, can't erase, I guess. Right, I can't out. Hello, eraser. Okay, so over here, we're simplifying once again. So here we have a 1 minus 1.05, and then that's going to be raised to the negative 36th power over 0.05, and now we can just do what we just did. So this will just be the same thing as 1 over, just kidding, 1 over 5 over 100 minus, we have a, I don't know, which would just be what, 100, so 105. This would just be 1 over 1, 5 over 100 times a 1 over a 1, okay, 1 over a 1 over, man, I can't do freaking math, I guess. Whew. Okay, hold on. Jesus, this is very hard to explain. So we have, this is very hard. So here we have a, okay, so I'm going to do it like this so I can just explain it a little bit better. This is going to be sitting as 1 because we have a negative. It'll just be over this. So it'll just be 0.05. And this will just be 1.05 to the 36, right? Because we just bring it down. Okay, so here, this is just going to be the same thing as a 5 over 100. This is just going to be the same thing as a 105 over 100, and then it's to be raised to the 36th power. So we can just multiply the, no, we can't do that. We can just flip it, right? So here we see that we can just combine these, so this would just be the same thing as 1 over, so this would be 100 over 5, and this would be multiplied by 1 over 105. This is very hard to simplify because it's so freaking weird. 100, so you can divide this by 5, of course. So this will just be divided by 5, this will be divided by 5, this will just be 100 divided by 5, which is going to be 20, right? So 105 over 100, maybe we shouldn't put this into a decimal. How the frick? Okay, I know you can just distribute this, which would just be, this would just be 100 to the 36th power, 105 and 100 to the 36th power. So, yeah. Okay, so what we have, this is very hard to explain. We have 100 over 5, which is just equal to 20. So we have 20, and then we have minus a 20 again, because we just flip it. And then we have a, but this is going to be times a 1 over that, which is just going to be a 100 to the 36th power over 105 to the 36th power. We see that we have a 20 on both sides, so this is just going to be factor out of 20. So we have a 1 minus a 100 to the 36th power over 105 to the 36th power, and then we can combine this, so we just have 1 minus 100 over 105 to the 36th power. Okay, and that's the answer. This is so hard to explain to you guys. But yeah, that's the answer. So hopefully that's how you're supposed to do it. That's how I do it. This is weird math. Haven't done this in a while, but yeah. There you go. With my OBS. There it is.